Okay, here we are. Algebra 8.5, exponential growth. This is a mathematical model that actually helps you interpret and understand how things grow fast. So the formula is written right down here for exponential growth. And this formula actually, right here, where the cursor's at, has different parts to it that you have to understand. And if you're good at using formulas like I am, it's easy to follow because all you have to do is memorize a formula. So this is what you start off with. Your starting amount of either money, so I'm going to say the amount you started with. Okay, that's what you started with. So if you are investing money and you start off with $200, that's where the 200 goes. The second part of this is this part right here, and this is known as the rate. It's usually represented as a percentage. So let's say you're investing money in a bank and it's giving you 4% interest. Okay, you can't use the percent. You have to change the percent into a decimal, and the way you do that is you put 4 and you move your decimal over 1 2 times. That gives you the 0.04 is the amount that would go into the rate. And lastly is this t right here, and this is the time. Each segment of time. Now, banks pay you an annual percentage rate. So in this case, it would be per year if you're investing in a bank or investing your money in a bank. But in some situations, the time may be in different segments. Like when you're borrowing money from a bank, the time is actually compounded every 3 months or something like that. So let's just say it compounds twice, which means the time would be every segment would be 2 times every year. If you're borrowing money, if you're lending money or giving money to the bank, it's only once per year. That's why it's so expensive to borrow money from the bank. So let's do some examples right now. Okay, here's a first example. Let's say I'm putting into the bank $1,000, euros, doesn't matter, kuna, whatever you're going to put in there. And the interest rate is 6.5%. And you're going to leave it in there for 5 years. These are the important parts of your word problems that you need to learn. So here's the amount. Well, if you go back up to the formula, which in this case, C is your beginning amount, you put Y is equal to 1,000. You put your parentheses. You put the 1 plus the rate. In this case, the rate is 6.5. The way I change this, I move the decimal over 2 places in order to make it a decimal, which gives me 0.065. 0.065. And you put the t up here, which is the amount of years, which is in this case, it's 5 years. Okay. I'm just going to tell you that in these cases, you pull out your scientific calculator because you're going to start needing to use it more often from this point on. It's almost obligatory that you use one at this point. So here it is. Let's do this. Let's do this in segments. Let's first do the parentheses because we got to use PEMDAS, right? So let's put these two together, and that gives me parentheses 1.065 raised to the 5th times 1,000, right? We added those together, combined these two. Now let's use PEMDAS to raise 1.065 to the 5th power, which this gives me now 1.37008663. Some long number. Doesn't matter because my calculator is the one that's going to do it. And from here, I multiply this by 1,000, which now will give me an answer. Let me roll this up, scroll this up so you can see it a little bit better. Which now this times 1,000 gives me 137 0.0866. Now, is there really a point zero eight six six pennies? No. So we need to round to the nearest hundredth, which will give us 1,370.09 cents. You got to put a label on there. And this is my answer. So if you follow the rules of PEMDAS, and you memorize this formula, it shouldn't be a big problem for you to do any problems that look like this at all. So remember, the important thing is the amount of money that you start with, the percentage rate or the interest rate, the rate that it's increasing, and then how much time is going on here. So here is in starting money, the interest rate, and the amount of time. And those are the factors you need to figure out these problems. Okay, here's the next kind of problem. It's exactly the same. You're using the same exact formula, which is right over here. Except this is a population growth. This is where I get excited because it talks about biology and stuff like that. And so this population growth, if you started off with 100 bacteria, that's the important number right there, and it doubles, what does the double mean in percentage-wise? You need to figure that one out in a second. Every hour. So my C in this case is the 100. The T in this case is every hour. That's a time increment. The question here becomes difficult because we need to ask ourselves, what does it mean to double in percentages? And so if you think about it a little bit, you actually realize that double means that if I started off with 10, and if it doubles, I end up with 20. And so that means that your interest rate is really 100%. And I'm going to do a little simple math over here to show you that, because so here it is, I'm going to go through this again. You have 10 times 100%, which 100% changed to a decimal is 1, is equal to 10, and this plus this is equal to 20, which means that's how much you end up at the end of it. So if you double it, you're putting it at 100%. So this equals, whenever you see the number double, it means 100%. Okay, so let's rewrite this formula, and let's rewrite the word problem into the formula, how it's written above. So y is equal to 100 bacteria, parentheses, 1 plus 100% as a decimal is 1, raised to the hour, which is, in this case, it's 8 hours. Which I'm going to work step by step. Remember, this is the best way to show you working. I can find your mistakes on the tests. Becomes 100 times 2, because 1 plus 1 is 2, raised to the 8th power, and 2 raised to the 8th power, because we're doing PEMDAS, parentheses next, is 256 times 100. And the easy way of doing multiplying by 100 is just add zeros to the end of it, which becomes 256, and you get 2 zeros at the end, 1, 2, which ends up to, in 8 hours, when you start off with just 100 bacteria, and the reproductive rate is 100% per hour, you end up with 25,600 bacteria. So this is an amazing amount of bacteria that grow, and that's why bacteria grow so fast, and you should wash your hands all the time. So the last part of this chapter is a conceptual, and they always want you to figure this out. So I'm going to give you a hint here. Whenever you see a exponential growth that increases real slow, the percentage is really low. The percentage is low percent. When it increases a little faster, the percent is a little higher. And I'm going to put higher compared to a low one over here. And when a percentage grows really fast, by the way, it never curves back on itself. It will always continue, and this is called like an asymptote, this number here, little dotted line. It'll always forever get closer and closer to that number, but never really pass a certain number. Is the percentage is really high. really high percent. So it depends on how you see these graphs. Notice that this one's a lot slower, this one is a lot steeper, and this one is really steep. And that's the difference between, that's one of the things you need to be able to realize. Now, if you start with the same slope on here like this, it's exactly the same as this one, it just means you started off with more individuals or less individuals. But that's how you determine the rate based on the graph.